Hey everybody, we're going to take a look at section 6.4, applications of linear systems. And if you look at the word applications, the root word is apply. So how would you apply this to real life? And I'm going to be completely honest, this is probably one of the tougher sections of the whole year. You just kind of have to wrap your head around this. But I'm going to try to help you answer 3 questions. The first one is, when will I ever use this? Or maybe not even yourself, but whoever uses this. Why do you need to know it, and how do you do it? So let's take a look. First of all, you need to be able to look at equations and decide which method to use. And if you look on page 383, they give you a really good little graphic in there that explains when to use each one. The first one for graphing, you're going to want to graph 2 equations when you need a visual, or when it's easy to do so, because some numbers don't lend themselves easy to graphing. Substitution you want to do when you have 2 equations where it's very easy to replace one with the other. And then you want to use the elimination method when you have coefficients of variables that are very easy to cancel. So, when might you use this someday, other than in algebra class? Well, you might want to use it when you are creating mixtures, solving rates, or finding break-even points. And I'll show you an example of each one. The first example is a break-even point, and companies and businesses do this all the time. They have to factor in their cost to create a product, and they know that they have to sell so many or so much to make a profit. If you have to pay so much to create something and you're not making enough profit, then you need to rethink what you're doing. So I am not going to use the examples in your book because I want you to have another reference point. So these will match problems 1, 2, and 3 from your book, but they won't be the same one. So you can go back and look at those and see what they did step by step, and it should match pretty closely with what I'm about to show you. So again, this would match problem 1 on page 384. So our first problem is printing a newsletter cost $1.50 per copy, plus an initial printer's fee of $450. So I'm going to write this down. It costs the company $1.50 per copy. And they also have to pay an initial $450 fee to the printer just to even begin their work. They profit $3 per copy. So for every copy they sell, they take in $3. So that means if they sell 1, they make $3. If they sell 2, they make 6. 3, they make 9. You get it. Okay, so what you first want to do is write these as equations. So I'm going to take this first one and set this up as an equation. Well, I know that it is going to cost me an initial $450. Also, $1.50 per copy. So I'm going to call that X. So X is talking about the number of copies. Y would obviously be my total. And it might be helpful as you get started to make a note of what your variables mean so that you don't mix them up or use the wrong ones. My second equation would be profit, and my total, my Y, would equal $3 times the number of copies that I sell. So here I have 2 equations talking about the same thing. Y is the total. This is the first one is my total cost. My second Y is my total profit. If you look at this, you can see that you already have this set up so that one is equal to the other. So what I could do instead of Y, I could plug in 3x. So I am going to do that up here. if I plug 3x in for y, oh, sorry, I should have drawn that over here because I'm plugging it in for y. If I plug that in, my equation becomes 3x is equal to, and I'm gonna switch the order here just because I like my constants at the end. So I'm gonna have 3x is equal to 1.5x plus 450. Now I only have one variable, so I can solve. So I can subtract 1.5x, and so that equals 1.5x is equal to 450. I'm running out of room, but that represents multiplication. So to solve the equation, I would divide by 1.5 on both sides, and I get, I'm going to write it right here. Once I solve that equation, I get x is equal to 300. Well, once I get that, I am going to plug that in to my other equation and see what that equals. If I plug in 300 for x, my y, 3 times 300, should be 300. So what I have so far, I have x is equal, excuse me, I have x is equal to 300 and y is equal to 900. You can go back and plug both of those in and make sure that you did it right. Well, if you plug in right here, if you plug in 300 right here, sorry, I'm making a mess of things. 1.5 times 300 is 450. And what's 450 plus 450? You got it, 900. So you know that that solution worked for both of them. So the question was, how many copies of the newsletter must be sold to break even? Well, when the cost and the profit is the same at $900, they've broken even. It's both $900. They would have spent $900. They would have earned $900 even. Okay. So as a company, they would sit back and say, we have to sell at least 300 newsletters to make a profit. And so then they're going to rework their business strategy to make sure that they sell at least 300 copies.